Categorical predictors. So often when we have categorical variables, each categorical variable actually has many levels or many categories. It's not just one or zero. And here we have an example of this called verified income in the loan data set. So there's three types of verified income. There's income that is just plain verified, there's income that is not verified, and there is income that is source verified. So there are three, and there could be four or five, but in this case there are three. So we can use multiple regression the same way as we have been explaining. So we can have this verified income as a predictor. So in this case, we're assuming the verified income can predict the interest rate. And we load this data into a regression model, and then we get the regression model, and then we get the results. And then we have the estimates here, the coefficients. But we have to do a little bit of transformation to actually understand this. And essentially, there's two steps that we need to do. So one is we need to create a dummy variable, a binary variable from each value, so from each category of a multidimensional categorical variable. By multidimensional categorical variable, I mean categorical variable that is not just yes or no, that has more than two possibilities. So for example, in this case, verified income has three: verified, not verified, and source verified. So what we need to do is create a binary variable for each of the categories, but -1. And this -1 is called the reference level against which the other two will be compared. And actually, I put the R code here, so this will be good for you to remember. So you can, for example, how do you create this dummy variable? So you can use an if-else statement. So we have the new variable is just going to be called verified. So this is a little bit confusing because the whole variable, the whole attribute is called verified income, and one of the levels is called verified. So, but I hope you can understand it. So one new dummy variable is going to be called verified. So df is the data frame, which is when we load the data set into R, that's called the data frame. So this is the attribute, the new attribute of the data frame. So if else verified income equals verified, then this variable will be 1. If not, it will be 0. This is the basic structure of the if else function, right? So what's going on here is if verified income, so it's going to check every row. You're going to go through every row. If this variable here, verified income equals verified, so in this case, it's going to put 1, and the second is going to put 0, and this checks every row. This is going to be 0. This is going to be 0. This is going to be 1. This is going to be 0. And this is the new variable, verified. I'm using the mouse, so it's very hard to write, but this is verified. This is a new variable we just created. And then we create a second variable, also source verified, which is a different kind of verified income. And then if else verified income equals source verified, then it gets 1 and then gets 0, and that's the same thing. So this is the new one. So this is going to be 0. This is going to be 0. This is going to be 1. This is going to be 0. This is going to be 0, and this is going to be 0. So in here, in this sample only has 1. And so on. And then notice, though, we don't create a third one. We don't create it for the third. So you have to choose which one you want to be the reference level based on the context, but you just have to use 2 and not it's just always -1. Let me show you how we interpret this. So the second step is we build a model with each of the dummy variables. So assuming we created 2, here we had to create 2 new variables. One is called just verified, and one is called source verified. And then we load these 2 variables in the multiple regression. Now remember, we're talking about multiple regression, so we can have multiple predictors. And we get the results similar like we did from the one predictor variable. And the missing category is called the reference level, and it represents the default level that the other levels are measured against. So for every level except the reference level, there is a coefficient result. The coefficient is interpreted in relation to the reference level. So in this example here, the interest rate goes up by 3.25%, this one here, or 3.25 points for those people who are verified compared to not verified. Okay, so the interest rate on average, in general, assuming everything else equals, the interest rates for those people who are verified goes up 3.25 points if they're verified compared if they're not verified. And how do you know it's up and not down? Because there's no minus sign. If there's a minus, if it's negative, it would be go down. So what about for source verified? Well, source verified is the same thing, right? So how much does the interest rate go up if the person is source verified compared with, once again, same thing, compared with not verified? Well, it goes up by 1.42 points. And just like we did before, we can create a more complete equation model with the coefficient results here listed. And then you can actually compute the interest rate based on the built model. And so why don't you try? You try what would be the interest rate if a person has only a source verified income, type of verified income, so type of income. So pause the video and try that. And actually, we're going to end it here and continue next time. See you.